Welcome back to the channel, Watertight Compartments. The principle is simple yet revolutionary. Divide the ship's hull into smaller, isolated sections. The primary purpose is subdivision and damage stability. If a ship strikes an object, like an iceberg or another vessel, and breaches its hull, water will rush in. Without internal walls, the water would flood the entire ship, causing it to lose buoyancy and capsize quickly. Watertight compartments act as independent barriers. By limiting the flooding to one or perhaps two compartments, the rest of the ship remains intact and buoyant. This design is often referred to as the compartmentation principle. The rules governing the construction and arrangement of these compartments are laid out in the International Convention for the Safety of Life at Sea, or SOLAS. SOLAS mandates specific standards for the location and height of watertight bulkheads, ensuring a ship can survive a defined level of damage. These compartments are created by watertight bulkheads, which are vertical walls running from the bottom of the hull, the keel, up to a specific safety deck known as the bulkhead deck. The bulkhead deck is the highest deck to which the main watertight bulkheads are carried. Crucially, all openings below this deck must be capable of being sealed watertight. The structure of these bulkheads is highly scrutinized. They must be strong enough to withstand the enormous pressure exerted by a flooded adjacent compartment. The difference in pressure between a dry and a water-filled compartment is substantial and must be accounted for in the structural design. Access between these compartments is managed through watertight doors. These are special doors designed to be completely sealed against water ingress. In modern ships, especially passenger vessels, these doors are often power-operated and sliding, and critically, they can be remotely closed from the bridge in an emergency. There are strict regulations on the operation and testing of these doors to ensure they function reliably when needed most. The overall effectiveness of the system relies on the concept of reserve buoyancy. This is the volume of the ship above the waterline that is available to keep the ship floating if the lower parts are flooded. By keeping the floodwater confined, the ship maintains enough reserve buoyancy to remain stable until passengers can be safely evacuated or temporary repairs can be made. Proper maintenance and operational discipline are just as important as the design itself. A watertight door left open negates the safety feature of the entire compartment. SOLAS requires regular drills and inspections to ensure the crew is trained and the equipment is fully operational. If you found this video helpful, please give us a thumbs up, hit the notification bell, comment, like, share, and subscribe for more insights. Thank you.